Welcome back, students. Let's go back to the logarithmic differentiation. Here are the log rules 1, 2, and 3, and we went through the logarithmic differentiation type 1 in the previous video when we have humongous product to a quotient. They were logarithmic differentiation method, kind of like this. Take the log, simplify, take the derivative implicitly, flip the denominator y to the other side, further simplify, and then plug in y as whatever that was before. That is the logarithmic differentiation. An alternative method is to use generalized product rule, express those as a big product, and then use the generalized product rule. I like the second method better, but our textbook's method is logarithmic differentiation. Now, another application of logarithmic differentiation goes kind of like this. When both the base and power are functions, in that case, how do you handle that? Well, we use the same technique. Take the log of both sides. And then we can simplify using the log rule, the third log rule. This power comes out as coefficient, and then what do you get? Log of x times log of x. You see, log of x came out. This thing, oh, it's so difficult to highlight this top portion only. Oh, come on, it's okay, I finally succeeded. That part is coming out as coefficient. And then what do you get in the end? We get log of x squared. And then we can just go ahead taking the derivative implicitly. Y prime over y, because we have to take the derivative of this left hand side, log of y. And the right hand side, we just take the derivative of this. 2 log of x to the first power, and then the derivative of the inside by chain rule. You don't have to write the first power, but I decided to write it anyway here. A little bit of simplification, what do you get? 2 log of x over x, isn't it? And please don't stop here, because this is where a lot of students stop. They get exhausted. We are looking for y prime, but here left hand side is y prime over y. So you have to flip this y prime to the other side, which is y times whatever you got before. Is this the end? Okay, but that's not really a complete solution, because what is y? This is y. So you have to bring it back. So that times 2 log of x over x, and that'll complete the problem. Or if you want to simplify this thing just a little bit, 2 log of x and then x to the log of x minus 1. Yes, we can do it like that, because log of x power, and basically this is x to the negative first power. Oh, never mind. The last line is too complicated. Here's the solution. Just a logarithmic differentiation. Take the log, simplify using the log rules, take the derivative implicitly, and flip the denominator to the other side and simplify. Here is the solution. Oh, why are all these hidden? Okay, there you go. We take log of both sides, take the derivative implicitly, and then flip y to the other side and express y as the original. And I did extra simplification here, which is not really necessary. Here's another problem. How do you handle that? Well, the same way. Take the log of both sides, and then bring this cosine up front. So you have cosine of x times log of x. See, this log was there before. That one is new logarithm. Can be confusing. And then we take the derivative implicitly, y prime over y, and then we use product rule, negative sign, and then log plus cosine, and then the derivative of this log. And then flip the denominator to the other side and reinsert the original denominator, log of cosine of x power times the computation we just did. Now, do you like this method? Personally, I don't. My favorite method is this way, using the change of basis formula. Let's write like this. A to the b power can be rewritten as natural exponential of b times log of a. And then we can apply the derivative for natural exponential function. Well, it's here. Rewrite this x over to this part. First log of x was there before. So after simplification, we get e to the log of x quantity squared. And then we simply take the derivative using the chain rule. This exponential stay the same and take the derivative of the inside by chain rule. 2 log of x and then 1 over x by chain rule. And you can stop here as a matter of fact. But if you decide to simplify, then please recognize that this is the original problem, and then you can further simplify. But this part is not really necessary. So basically this is a kind of problem that you can work out the entire problem in a single step almost. Let me show you the second problem using the alternative method. So how does that work? Change of basis formula like this, and change this into exponential, and this log goes over there, log of the base. So we have log of x. And then we take the derivative using the chain rule and inside product rule. So we have something like this. Exponential stay the same, and then this is the derivative of the inside using product rule and then the chain rule, and that's where the problem actually ends. The other two steps here are just simplification, which are not really necessary. A little bit further simplification, a little bit further simplification, but these are not really necessary. The problem actually ends here, almost a single step. This is the method I prefer. In short, I don't use logarithmic differentiation at all. And if I have it entirely my way, I wouldn't be teaching it at all either. But no, I can't do that, especially when I have to prepare students for a standardized exam. That's why I'm covering it. You have logarithmic equations, and if you're doing especially multiple choice problems where all the choices you have are a form of logarithmic differentiation, then you're stuck here. Otherwise, you can use an alternative method, which are, in my opinion, superior.